Hey everyone, welcome back. Today we are talking about a core concept in building systems, failover. Failover is a critical mechanism used to ensure the systems stay online and operational, even when things go wrong. In this video, we will explore what failover is, how it works, different types of failover, and real world examples of where, of where it is used. Let's dive in. So, first, what is failover? Failover is a mechanism that allows a system to automatically switch to a redundant or backup component when the primary component fails. It ensures that your system continues operating without significant disruption when a failure occurs. For instance, imagine a database that suddenly crashes, and instead of going offline, the system seamlessly switches to a backup database so users don't experience any downtime. This process is what we call failover. Okay, why failover is important? Failover is important because it first maintains availability. It basically keeps services running even if something breaks. Second, it minimizes downtime. Automatically switching to backup components helps minimize or eliminate downtime. And third, it enhances reliability. Failover ensures reliability by providing a full backup when the primary system fails. Things of a failover like having a spare tire for your car. If one tire goes flat, you have a spare that allows you to keep moving without being st- stranded on the side road. In the system design, failover in is the spare tire that ensures continuous service. Okay, let's talk about the types of failover. There are two famous types: active passive failover and active active failover. Let's start with active passive failover. Active passive failover involves a primary component that is actively serving requests and a backup component that remains idle. If the primary component fails, the backup becomes active and takes over. For example, in web application, you might have a primary server actively handling all user requests and a secondary server on standby. If the primary server crashes, the standby server takes over. This switch is called failover. So, the second thing is active active failover. Active active failover involves multiple active components that are all serving requests at the same time. If one of them fails, the other one takes over its workload. A good example of active active failover is load balance system with multiple servers. All servers are actively processing requests, and if one fails, the other seamlessly pick up the slack without any downtime. Okay, let's look and try to understand how failover works. Failover works on three steps. The first thing is the failure detection. The first step of how the failover works, first, failure detection. The first step in failover is the failure detection, as I said 4 times until now. Systems use health checks to continuously monitor the status of components. If a failure is detected, the failover mechanism is triggered. For example, in a database cluster, health checks might ping the primary database at regular intervals. If it doesn't respond, the system knows it's time to initiate failover. The second step of how the failover works is switching to backup. After detecting a failure, the system reroutes traffic to a backup component. This can be done using tools like load balancers or automated scripts that make the backup components active. Um, like in AWS setup, for example, you could use Elastic Load Balancer to distribute traffic between multiple instances. If one instance fails, the load balancer stops sending traffic to it and directs users to healthy instances. And three, the fail back process. Once the primary component is fixed, the system can undergo a process called failback, where it switches back to the original component, often during a low traffic period to avoid disruption. Okay, let's talk about a real world applications of failover. The first thing that we could talk about is the cloud service provider. Cloud service providers like AWS and the Google Cloud use failover mechanisms extensively. They replicate data across multiple regions so that if one region experiences an outage, services can fail over to another region, ensuring uninterrupted availability. And also in financial systems, failover is crucial because even a few minutes of downtime can lead to significant financial losses. Banks often use active setups where transactions are processed by multiple servers simultaneously, ensuring that a server failure doesn't disrupt services. Okay, let's talk about some challenges in implementing failover. While failover is a powerful strategy, it does come with its challenges. The first one is the cost, because maintaining redundant systems, especially in active setups, can be really costly. Second, complexity. Configuring automated failover and making sure all components sync correctly adds complexity to the system architecture. Third, data consistency. Because during failover, ensuring that no data is lost or duplicated is a major challenge, especially in distributed databases. For instance, in a database system, if a failover happens while data is being written, you need to ensure that the backup database is in sync to avoid inconsistencies. This is why synchronous replication is often used, but it can add latency. Okay, let's talk about best practices for implementing failover. The first thing, which is regular failover testing. One best practice is to regular test failover mechanisms. This sometimes referred to as disaster recovery drills. If you don't test your failover process, you don't know if it will work during a real failure. Use health checks and monitoring. Always use health checks and monitoring to detect failures early. Tools like Datalog can help continuously monitor the health of components and alert you when something goes wrong. Third, automate the failback process. The failback process should also be automated to minimize manual intervention. Once the primary component is healthy, automated scripts can shift traffic back smoothly without affecting users. So, in conclusion, to sum up, failover is a vital mechanism for maintaining high availability and ensuring resilience. We discussed here different types of failover, including active, passive, and active, how failover works from the failure detection to switching and then failback. Third, we talked about real-world examples of how failover is used in cloud services and financial systems. In the next video, we explore more on disaster recovery and how to design systems that can bounce back from major failures. If you found this video helpful, make sure to subscribe and like and hit the notification bell so you don't miss out any new videos. See you.